Hello, and welcome back to another IB Math speedrun with me, Vince. In this speedrun, we're going to be continuing our exploration of Chapter 7.2, and now we're going to be focusing on logarithms. So let's jump right in. So, what is a logarithm? Well, we already know what an exponent is, right? We have like a number is equal to another number raised to a power. Well, a logarithm, if we have these exact numbers, is equal to, the power is equal to the log of b base b times a. So a and b are of course positive real numbers, and b is not equal to 1. So this b is called the base, and this a is, well, I mean, the value, and then x is the exponent. So it's sort of like a reverse exponential function in a sense. So it allows us to convert backwards, and allows us to solve like equations like these more easily, especially if we have to solve for a power. So yeah, logarithms have several properties. So first of all, log ax plus log ay. So if they have the same base, of course, because they're powers, we multiply them together, log axy. So this holds true. So if we're adding logarithms, we multiply with the same base, we multiply the things inside them. If we're subtracting them, then it's equal to dividing them, the parts inside. Next, if we're raising something inside a logarithm to a power, this is equivalent to multiplying the logarithm by that number, since it's like raising a power to a power. Next, of course, log of any number of 1 is equal to 0, and a log of any number of itself is equal to 1. And then some more stuff. The negative logarithm of a number is equal to the logarithm of 1 over that number. And finally, one more useful property is that log of a to the x is equal to, we can split this into two separate logarithms, both with the same base, any base b, and it's equal to those two divided by each other. And so, I mean, following this, log a to the b is equal to 1 over log b to the a. So those are the properties we need to know about, and now we can use them to solve some problems. So yeah, let's jump into some problems. So first problem, I'll do the odd ones again, is express each of the following in logarithmic form. So the first one is 3 to the 5 is equal to 243. How we express this in log form is, remember, we have log and then the base, which is 3, then the actual number it results to, 243, is equal to 5. It's like saying, in order to get 3 from 243, we have to raise it to the power of 5. Next, we need to express p is equal to q to the 5. So this would be log qp is equal to 5, since in order to get from q to p, we need to raise q by 5. Next, we have x to the y is equal to 11. So we have log x 11 is equal to y, since in order to get from x to 11, we have to raise it by y. Next, write each of the following in exponent form. This one is log 64 to the 8 is equal to 1/2. So in order to write this, we remember that 64 to the power of 1/2 should be equal to 8, which is correct, of course. Next, we have log mn is equal to p. And so in order, oh sorry, this is the wrong one. We actually have log b to the 1 is equal to 0, and this is equivalent to saying b to the 0 is equal to 1. Next, we need to solve for x. So the first one is log x to the 2 is equal to 128. So in order to solve for x, let's rearrange this. So we get x to the 128 is equal to 2. And so x is equal to the 128th root of 2. I'm not too sure. I don't think we have to expand that. Yeah, we don't. It's just the 128th root of 2. Next, we have log x to the 8 is equal to 3/4. And so we can rearrange this to say x to the 3/4 is equal to 8. And so therefore, x is equal to 8 to the 4/3, which is equal to 16. Next, we have log x to the 49 is equal to 2. So we have x squared is equal to 49, and so x is equal to 7. So yeah, pretty simple. Next, we need to express the following in terms of log a to the m and log a to the n. So first one, we need to express log a to the root m over n cubed to the 2/3 in terms of log a m and log a n. So the first thing we do is we remove the exponent. So this is equal to 2/3 log log base a of m to the 1/2 n cubed. And so this is also equivalent to saying, n to the 1/3. N to the -3, sorry. Oops. And so this is also equivalent to saying that we have 2/3 log a of m to the 1/2 minus 2/3 log a of n to the -3. And so we can remove the powers once again. So this is equal to 1/3 log a of m minus 2/3 2 over -3 times -3 is equal to, oh sorry, this should be plus still. So this is equal to -2 log a to the n. So yeah, that should be the correct, this should be the correct answer. Yeah, that's correct. Okay, next we need to express each of the following as a single logarithm. So we need to express log 3 to the 36 minus 2 as a single logarithm. And so in order to do this, we need to know that 2 is equal to log 3 to the 9. Since to get from 3 to 9, we have to raise it by the power of 2. So this is equal to log 336 minus log 39. And when we're subtracting logs by the same base, we divide them. So this is equivalent to log 336 over 9, which is 4. So this is the answer. Next, we need to express each of the following as a rational number. Log 2 to the 12 minus log 2 to the 48 minus 3. So we want to convert, first of all, we want to convert 3 into a logarithm of base 2. So this would be log 2 to the 8. And so now we can subtract these. So this is all equal to log 2 to the 12 over 48 times 8, which is equal to log 2 to the, well, 12 over 48 is 1/4 times 8. This is 1 over 32. So this is simply equal to -5. Since to get from 2 to 1 over 32, we need to raise 2 by -5. So that should be the answer. Okay. Next one, express a in terms of b. 4 log a is equal to 3 log b. And so we need to express a in terms of b. When we don't put a base on the logarithm, that normally means we're taking the 10th, we're using base 10 as the logarithm. In this case, is to express a in terms of b, we can divide these logarithms, I guess. Yeah, so we have 4/3 log a over log b is equal to 1. And notice when we're dividing logarithms with the same base, this is equivalent to saying 4/3 times log of I believe it is B, A. Yeah. Yeah, so we can, this is equivalent to saying it's equal to that, is equal to 1. And so we have B to the 3/4 is equal to A. Yeah, so that is the answer. Yeah, it's correct. Okay, next one. We have log B is equal to 1 minus 4 log A. So first let us add these two together. So we have 4 log A plus log B is equal to 1. This is equivalent to saying log A to the 4, B is equal to 1. And in essence, since this is log 10, we're saying A to the 4 times B is equal to 10. So A is equal to the 4th root of 10 over B. I think that should be correct. Yeah. Next, we need to evaluate the following. So we need to evaluate log 6 to the 10 times log 36, which is, of course, log 10 to the 36. So what we can do over here is we need to convert this into a logarithm with base 10. And so we can do that by saying it's equivalent to log 10 base 10 over log 10 base 6 times log 10 36. So we know log 10 base 10 is equal to 1. So simply 1. So then we can evaluate this as log 10 36 over log 10 6, which is equal to log 6 36, which is equal to 2. So that is our answer. So the entire expression was equal to 2. Yeah. Next question, we have log 5 to the 8 over log 25 to the 8. Yeah, so what can we do here? We can convert this log 5 to the 8 into a log 25. Actually, if we think about this, this should just be equal to log 5 to the 16. Since if we think about the properties of logarithms, if we have log a to the b is equal to x, where a to the x is equal to b, then if we say a squared x, what is the value of a squared x? Which this will be equal to b squared. So we have log a squared b squared is equal to x. So we have why is that copied? Anyways, log 25 to this should be equal to log 5 to 8 over 2. No, it's actually square root 8. I think I'm confusing myself here. Let's just do it normally. Anyways, we have logarithm of 25 to the 8. And so what we can get from this is, yeah, no, I think I was correct. I think that if we square root this, we can also square root this, and it should remain the same answer. So this should be 5 root 8. So what we have is log root 8 times 8, log 8 of root 8, which is simply 2. Since root 8 squared is equal to 8, so yeah, that's correct. Whoops, confused myself a little. Okay, next one we need to evaluate log 5 to the 40 minus 1 over 2 log 64 to the 5. Okay, so this is equal to 1 1/2 times log 5 to the 64. So that's equal to, if we multiply it again, this is 64 to the power of 1/2, which is 8. So we've log 5 to the 40 minus log 5 to the 8, which is equal to log 5 to the 5, which is equal to 1. So yeah, that is the answer. Next, show that 1 over log x of xy plus 1 over log y of xy is equal to 1. So we obviously have to convert these into terms of xy. So we have what would be the best way to do this? I guess convert both into bases of xy. Let's think. So in essence, what this is saying is log y to the xy plus log x to the xy is equal to the multiple of both. So log x to the xy, log y to the xy. Oh, actually, no, wait, this is so much easier to prove. What am I doing? Ignore all of that. Since we know that, let's go back. It's lagging. Since we know that 1 over log x to the xy, this is equal to, this is equivalent to log xy of x plus log xy of y is equal to 1. And since we add these two together, we can simply log xy to the xy. And this is, of course, equal to 1 since same base. So yeah, that is correct. Next, let p is equal to log ax, q is equal to log ay. Express show that log xy to the a is equal to 1 over p minus q. Okay, so I mean this is equal to 1 over log ax minus log ay, so this is equal to 1 over log ax over y. And so we can simply flip the two ones around to convert it out of a fraction form. So this is log xy to the a. So that's exactly what we needed to prove that it equaled, I believe. Yeah. Next, use technology to solve the following equations. 5 to the 3x minus 1 is equal to 12. So yes, you could use a graphical calculator, and you know, I guess you could do that. But if you don't have a graphical calculator, what you can do is you can say log 5 to the 12 is equal to 3x minus 1. So we have log 5 to the 12 plus log 5 to the 5 is equal to 3x. So we have log 5 to the 60 is equal to 3x. So we need to get 1/3 of log 5 to the 60 is equal to x. So we have log 5 to the 60 to the 1/3 is equal to x is equal to, of course, it's going to end up as a fraction. I mean, not as a fraction, as like a decimal. So let's punch it into calculator. 60 to the power of 1/3 is equal to like around 3. And we have log of that over log 5, and we should get something like 0.848, I think. That should be correct. Yeah, 0.848. So of course you could use like nsolve or a graphical calculator if you had one, but that's how to do it if you don't. Next, solve the following equations. Log 5 to the x is equal to 9 log x to the 5. Pretty simple. Let's flip this one around. So we have 1 over log x to the 5 is equal to 9 log x to the 5. So if we multiply both sides by log x to the 5 and divide by 9, we have 1/9 is equal to log x to the 5 squared. So we have log x to the 5 is equal to plus or minus 1/3. So we have x to the 1/3, x is equal to 5 to the power of plus or minus 3. So this is equal to 125 or negative 125? I think there are two answers, yeah. 125 or 1 over 125 are your two answers. Next, we have 2 to the x. No, wrong question. We have log 4 to the x plus log x to the 4 is equal to 2. So easy quadratic equation. What we need to do is we need to flip one of these around. I'm going to take 1 over log x to the 4 plus log x to the 4 is equal to 2. So what we have over here is we have, if we multiply everything by log x to the 4, we have log x to the 4 squared minus 2 log x to the 4 plus 1. So of course we can factorize this into log x to the 4 minus 1 squared is equal to 0. So log x to the 4 is equal to 1. So x equals 4. Yeah. Wait. How's it 49? I think they flipped the answers around. Anyways. Yeah, x equals 4. Next, we need to solve the equation log 2 to the x plus log 4 to the x is equal to 9. And so as we saw earlier, we can convert this into 4 to the x squared. So we have log 4 to the x squared plus log 4 to the x equals 9. So this is 3 log 4x is equal to 9. So we have log 4 to the x is equal to 3. So we have x is equal to 4 to the power of 3 is equal to 64. Yep, x equals 64, that's correct. Okay, next one. 16, solve the equation 4 times 9 to the x plus 3 times 4 to the x is equal to 13 times 6 to the x. Ooh, okay. So, what would be the best way to do this? I mean, this is 4 times 3 to the 3 squared to the x. 3x to the squared plus 3 times 2x squared minus 13 times 2 to the x times 3 to the x. Yeah, this is equal to 0. So I believe we can factorize this. Into, let's just say 4 times 3 to the x minus 1 minus 2 to the x times 3 times 3 to the x minus 3 times 3 to the x. Hold up, am I getting confused? 3 times 2 to the x is equal to 0. Since that's negative 12, negative 13, yeah. So in this case, we have either 4 times 3 to the x is equal to 2 to the x. So we need to convert these all into logarithms, really. So we have, sorry about that. Anyways, 4 times 3 to the x is equal to 2 to the x. So 3 to the x is equal to 2 to the x minus 2. So we have, I mean, I guess we could just take the logarithm at this point. So we have log 3, x log 3 is equal to x minus 2 log 2. So we have x times log 3 minus log 2 is equal to negative 2 log 2. So x is equal to negative 2 log 2 over log 3 minus log 2. So this is equal to negative 2 log 2 divided by log 3 minus log 2. So I'm getting negative 3.42. And I think that should be a correct answer. Let's just check. Yeah, that's one of the correct answers. And so of course now we have to evaluate the other side, which is this. So we have 3 to the x is equal to 3 times 2 to the x. So 3 to the x minus 1 is equal to 2 to the x. So we have x minus 1 log 3 is equal to x log 2. So we have x times log 2 minus log 3 is equal to negative log 3. So we have x is equal to negative log 3 over log 2 minus log 3. And it doesn't matter what base these logarithms are in too much. So we have negative logarithm 3 all over log 2 minus log 3. So I'm getting 2.71 as the other answer. So these should be the two answers for that question. Okay, next one. We have solve these simultaneous equations. 3 log a to the b is equal to 1 and a times b is equal to 16. Well, we can simply substitute a is equal to 16 over b. So 3 times log 16 over b to the b is equal to 1. So log 16 over b to the b is equal to 1/3. So we have, what do we have here? We have 16 over b to the power of 1/3 is equal to b. Or in other words, 16 over b is equal to b cubed. So we have 16 is equal to b to the power of 4, so b is equal to plus or minus 2. And so a is therefore equal to plus or minus 8, I believe. Let's check that. Oh, okay, yeah, but technically b has to be positive since we can only have positive numbers in logarithms, so there should only be 2 and 8, so these should be the two answers. Yeah. Next, we have to solve log 4 to the x is equal to y is equal to log 16 to the 6x minus 9. So, I mean, we can ignore y and we can just solve this directly. We know that this is equal to log 16 to the x squared is equal to log 16 to the 6x minus 9. So, of course, x squared is equal to 6x minus 9. So we can factor this into x minus 3 squared. So x is equal to 3. And y is equal to log 4 to the 3, I believe. Log 4 to the 3. So this would be a logarithm of 3 over logarithm of 4. So y is equal to 0.792. Yeah. So these should be the two answers. Yeah. Next, there's a lot of questions. I think we're on the final question though, so yeah. So a rubber ball is dropped from a height of 5 meters. Each time it hits the ground, it bounces up to a height of 7/8 of the height of the previous bounce. Determine how far the ball has traveled just before it hits the ground for the third time. Next, write an expression for the distance traveled by the ball when it hits the ground for the kth time, and C, calculate the maximum number of times the ball hits the ground before the total distance exceeds 39.5 meters. Okay. Determine how far the ball has traveled just before it hits the ground for the third time. So it's dropped from 5 meters. 5. And then we have 5 times 7/8 times 2. So we have effectively 5 times 7/4. And then we have 5 times 7/8 squared times 2. Actually, I should just write this in terms of 5 times 7/8. So we effectively have a geometric series here with starting term 10 and common ratio 7/8. So in order to get the sum, ball has traveled before it hits the ground for the third time. Actually, we need to calculate this manually because this is going to only in, actually no, it would, yeah. This would be a geometric sequence, so it would be first term 10, common ratio 7/8, and actually, I mean, technically we have to subtract 5 from the sum. So we have the first term, 10/1 minus 7/8. Wait, this is for infinite series though, so what can we do here? I mean, yeah, it will actually tend to a number. That's quite interesting. So we have 1 minus r to the n over 1 minus r. So we have a to the 1 over 1 minus the ratio to the power of n. So in this case, 7/8 to the power of, how many? 3 over 1 minus 7/8. So this is equal to, I mean, technically minus 5. So we have 1 minus 7/8 cubed divided by 1 minus 7/8 times 10 minus 5. So I got that it traveled 21.4 meters after the first 3 bounces. Next, write an expression for the distance traveled. We can do that. This is simply 10 times 1 minus 7/8 to the power of n, k over 1/8. So 8 times 1 minus 7 to the power of 8. So this is equal to 8 minus 8 times 7 to the power of 8. Minus 5. Actually, I think we need to start at one below this. Yeah, this is 21.4 meters. And so I'm getting this expression The book gives, I think, something a bit different, but that's okay. And now 39.5 meters, so we have to say that 39.5 is equal to 10 times 8 minus 8 times 7 over 8 to the k minus 5. So we have effectively 44.5 is equal 4.45 is equal to 8 minus 8 times 7 over 8 to the k. So we have 8 times 7 over 8 to the k is equal to 8 minus 4.45, so 3.55. So we have 7 eighths k is equal to this divided by 8, which is 0.44375. And so now we can just use a logarithm. This is log 7 over 8, 0.44375 is equal to k. So if we punch this into a calculator, this is equal to 6.08. So effectively, this is around equal to 6. So it will bounce 6 times before exceeding this distance traveled. So yeah, that was all for the speedrun. I hope you enjoyed it, and I hope to see you in the next one. See you then.